In question 1, we're told that a caravan costs £20,000 and we've got to work out the value after 3 years, given that it depreciates 11% in year 1 and then 6% in years 2 and 3. So slightly tricky question in that the depreciation rate is not constant over the whole time period as it normally is in a question like this. So let's just deal with year 1 first. So we're just going to take the starting value 20,000. We need to reduce that by 11%. You can either work out 11% and then take that away, or a smarter way to do it is just to multiply by the decimal 0.89. 0.89 because 100 minus 11 is 89%, and the decimal equivalent of that is 0.89. So literally just putting that in the calculator, I did this earlier, it comes out to be 17,800. So that's 17,800, that becomes our starting value. Now for the next calculation. The next calculation will be to depreciate that value by 6% twice, so over 2 years. So the same process, take 100%, take away 6% because it's decreasing. If it was increasing, you would add it to 100. That gives you 94%. The decimal equivalent of 94% is 0.94. And then we can either calculate that twice, or more efficiently, we can just put a power of 2 onto the 0.94 and then just put that in the calculator to get the final answer, which is 15,728 and 8 pence. Just remembering this is a monetary value, so you would then need to present that with a pound sign. So that is the value after 3 years. Moving on to question 2. In question 2, we're told that the mass of a helium atom is this very small number given in scientific notation or standard form. So 6.64 times 10 to the minus 24. So a bunch of zeros basically in the front of that number. Typically though in these questions you don't really need to work with the number with the zeros. That's why it's in standard form in the first place. It's just purely a calculator exercise once you've figured out what the question's asking. So that's the mass of one helium atom. We're told that the flask contains 300 grams of those helium atoms, and we've got to figure out how many of the actual atoms there are. What is the number of atoms in the flask? So just a fairly straightforward calculation, apart from the fact that the numbers are kind of weird, or at least this number is, but it's just going to be the total weight of the flask, 300 grams, and we're going to divide that by 6.64 times 10 to the minus 24. Probably don't actually need the grams in there. Let me just take that out of there. Okay, so just basically putting that in the calculator, just a calculator exercise, making sure that you know how to use the times 10 to some power button essentially. So I did this one earlier as well. This comes out to be 4.518 times 10 to the power of 25. So typically in a question like this, the calculator will just present the final answer already in standard form or scientific notation. The only thing to be careful with is to do with how many decimal places, or in this case, significant figures we want. So we want 3 significant figures, so we're just going to round that to 4.52 times 10 to the 25. In question 3, we've been asked to calculate the length of the arc from A to B. So just really a straight up use of the arc length formula. Obviously that formula is not on the formula sheet, so you need to remember it. So the length A to B, that arc length, is equal to the angle. Let me just write the formula first actually. So it's going to be the angle which we can directly get from the diagram, divided by 360. This is a tricky part, remembering which one's pi d and which one's pi r squared. So for arc length, our question, it's pi d. For sector area, pi r squared. So we've got all the information we need in this question just to plug directly into the formula. So our angle is 106. Got to remember as well that we're dealing with diameter in our question, but we've been given the radius because that part there would be the radius of the circle. Remember, this would sweep all the way around, meaning that would be the center point. So you've got to be careful with that. Easy to use the wrong number. So 106 over 360 times pi times the diameter. The diameter is going to be this number, the radius doubled. So 9.15 times 2. You can do that as a little bit of side working. That's going to be 18.30 or 18.3. So times 18.3. And it's literally just a calculator exercise at this point. So just putting this one in the calculator, I did this earlier and it comes out to be 16.9. So it's not one of these questions where you need to work backwards and figure out something that's not going to be already in the formula. You're just putting everything into the formula, working out on the calculator. This one was in meters, so remember to present that as meters. And just checking the diagram, does that answer make sense? Well, if that length there is 9.15, could that be 16.9? Seems sort of reasonable, it's in the right ballpark, so that is actually the correct answer for that question. In question 4, we've been asked to find the size of the angle JKL. So JKL, K being in the middle, that means it's this angle in here. So looking at the triangle, obviously it's non-right angle, that means we cannot use Pythagoras or SOHCAHTOA, so it's a sine or cosine rule question. The question then becomes, which of those rules are we going to use? So we've only got 2 side lengths. If we were to try and use the cosine rule for finding an angle, we need all 3 side lengths according to the formula sheet. So cosine rule goes out the window, meaning it has to be the sine rule. So just fully labeling the diagram, this would be lowercase l, this would be lowercase k, and this would be lowercase j. So it's good to get those fully labeled up. We can see that this angle in here that we're trying to find is actually uppercase K, and we can see we've got the side length opposite that. So in the sine rule, these are sort of paired up. So that's one pair. The second pair is going to be the J's, meaning that we don't actually need the L's at all. So you don't need to necessarily set up the full sine rule because you're only using 2 out of the 3 sort of parts of the formula. So setting that up with the K's and the J's, so maybe do the K's first actually, because that's what we're trying to find. So remember the formula sheet gives you an A, B, and C. We're just going to adjust that to make it K, J, and L. So putting the K over sine K and sine that equal to the J over sine J. And we're just going to lose the L's, right? Because we don't have information about L, we don't need the L. So that's everything we need. We can just start to populate that now. So little k is 10. Remember that uppercase K is what we're trying to find, so we'll just leave that as sine K for the time being. Small j, little lowercase j is 7. And then angle J is this one down here, which is 25. Remember the formula sheet presents the sine rule this way, but you can also flip these if you're trying to find an angle. That makes the algebra a little bit easier. So either at this point cross multiplying or flipping them. I'm just going to flip them. So that would give us sine K over 10 on the first fraction equals sine 25 over 7 on the second. Then we can just rearrange first of all for sine K. So we're going to get sine K. Eventually we're going to try and get K from that. We'll get that by multiplying both sides by 10. So it's going to be 10, basically moving on a diagonal. So the 10 moves up here. So it's going to be 10 sine 25 degrees divided by 7. So just a case of really putting that in the calculator at this point. I did this one earlier and it came out to be 0.60374. 0.60374. Remember those decimals will probably in most cases carry on forever. So we need to use either the full kind of number or at least sort of 4 or 5 decimal places in these. So the next step is to use the inverse of that number. So sine inverse of 0.60374, etc. And that comes out to be 37 degrees. Does that seem reasonable? Well, looking at the diagram, if that's 25, that's obviously quite a large angle, greater than 90 degrees. These need to add up to 180. That seems like, based on that, it could be around 37. Yeah, so just by looking at the diagram, it does kind of make sense. So that's the angle there for JKL, 37 degrees. In question 5, we're trying to find the size of the shaded angle. The shaded angle is from this horizontal line all the way to this line here. So notice that that's kind of spanning over 2 parts of the shape. So this part here and this part here. If we can find both of those and then add them together, that'll give us the total of the angle that we're looking for. So this is a geometry question, a properties of shapes question. So we can see in the question already that because these lines are at a right angle to each other, then on this side, then that must mean that this in here is also going to be a right angle, because obviously in a straight line they add up to 180 degrees. So why is that useful? Well, it's useful because the total angle we're trying to get is from here all the way to here, meaning that we can just now focus on finding this bit and then add it to the 90 degrees. to get the total. So I've only drawn part of the shape, but they're telling us that this part here is a 10-sided shape, a decagon. So that means that all the way around, obviously, would be 360 degrees, but dividing that by 10 to get the angle inside each of the shapes at the center point would be 360 divided by 10, given 36. So it'd be good practice to actually write that as working. So 360 divided by each of the shapes, 10, or each of the parts of the shape, 10 is going to give us an angle in there of 36. So that's going to be 36 in all of them. Let me just put a 36 into there and another one into there. We know that this is an isosceles triangle because these two are going to be the same. So that tells us we could work these out by just going 180, because all the angles in a triangle add up to 180, minus that 36. That's going to leave these two angles added together, and then just divide that by 2. So all of that divided by 2. So that's going to give us 180 minus 36 is 144, divide that by 2 is 72. So each of these angles, so that would be the angle here, here, and in fact in all of the shapes, all of these are going to be 72 degrees. So keeping in mind what we're looking for this angle here, but notice that in the same way that obviously that side adds up to 180 because it's coming off a straight line, this side adds up to 180 as well. So that there's 72 degrees, that's 72. We're trying to find a little bit in between those. So if we just do 180 minus 72 twice, or minus 72 minus 72, that's 180 minus 144, which actually goes back to that 36 number. So it's going to be 36 degrees. So it tells us that this angle in here is also 36 degrees. That tells us our total angle is going to be 90 degrees plus 36, which is 126 degrees. In question 6, we're told that Nadim bought a flat last year and it's increased in value by 8% and it's now worth 94,500, and we've got to work out how much it was worth originally. So this is a typical classic reverse percentage question. Very tempting to just work out 8% of this number and take it away or something, but it doesn't quite work like that. So different ways to set these up, but essentially if it's increased by 8%, this value represents 108% of the original value. So we can just set this up by saying that 94,500 is equal to 108%. And what we were trying to get to in this question is 100%. That's the original price. Smart way to do that is to take this down to 1%, and you can take it down to 1% just by dividing this equation on both sides by 108. So if we divide 108% by 108, we're going to get 1%. And if we divide this number also by 108, we'll get whatever that value is worth. So this value came out to be, I'll just check that one, 875. So £875 represents 1%. We want to get up to 100%, so now just times in both sides by 100. That'll give us the 100% value. So this number times 100, just putting a couple of zeros on the end. So 87,500. And that would be the price that Nadim originally paid for the flat. So typical reverse percentage question. That one, no real magic, no real trickery going on there. Just need to know the technique. Okay, and remember the units. So the next question is changing the subject of the formula, rearranging it to try and make M the subject. At the moment, P is the subject. So just a few lines of algebra to make M the subject. In other words, making the M term on its own and all the other terms on the other side of the equation. So a lot of students muddle these because they focus on the subject letter, but really in a way it's the other letters we need to focus on because we need to move those away from what we want to be the subject letter. So starting, I think in this case, by adding R to both sides. So we're going to get P plus R equals 1/3 N. Probably the next best move, although there is a little bit of personal preference in these, but I think the next best move would be to get rid of the 1/3 by multiplying each term by 3. Remember, this is all one term. If you multiply that term on the right-hand side by 3, it would just make the 1/3 times 3 a 1, but we don't need to write in the 1, so essentially we're just left there with mn. Multiplying the other side though by 3, you could either make it 3p plus 3r, or just go 3 bracket p plus r. Either way would be fine. That's probably the more concise way to do it. and then we want to get it all the way to m. That means we need to divide by n, because at the moment the m and the n are multiplying together, so doing the opposite on the other side of the equation. So it's going to be 3 bracket p plus r, all of that divided by n. Then maybe just spinning this around, put the m on the left hand side, so m equals 3 bracket p plus r divided by n. In question 8, we're being asked to determine whether the wall, which is this part here on the diagram, is perpendicular to the ground, which is this part here. Perpendicular means right angled, so essentially we want to know, is this a right angle? Certainly looks like a right angle, but you can't judge it just by looking at it. We need to test whether it's right angled by using Pythagoras. In particular, the converse of Pythagoras, when we're using the numbers to determine whether the triangle is right angled or not. So how do we go about this? Well, we start by testing the two short sides, because in the Pythagoras equation, those are squared and added together. So we're just going to go 7 squared plus 4 squared. Remember, we don't know if that's going to be equal to 8 squared. That's what we're testing. It will be if it's a right angle triangle, but if not, then it won't be. So don't set it equal to 8 squared. Just work out what you get, and then we'll work out 8 squared separately and then compare them. So 7 squared is 49, 4 squared is 16, so adding those together we get 59, 65. Okay, so that would be the two short sides in the Pythagoras equation. The long side is 8, so we've only got one number to work with there. So doing this as a separate piece of work in, so 8 squared is 64. So you can see the numbers are not the same. That means that it's not a right angle triangle. So you need to write some kind of statement for this. So you could say something like, since 65 is not equal to 64, and also by the converse of Pythagoras' theorem, the triangle is not right angled. And then I guess to fully respond to this question, you would need to then say something like, so the wall is not perpendicular to the ground. So fairly straight up use of the converse of Pythagoras, and then some kind of statement just to tie that all together. In question 9, we're asked to work out the volume of the block. You can see that it's like a square-based pyramid, but it's a square-based pyramid with the top part chopped off. But the part that's been chopped off is also a square-based pyramid, so essentially it's the difference between the two. So we're going to have to work out the volume of both square-based pyramids and then subtract the smaller one from the bigger one. So I've not drawn the diagram here, but you can just check that one yourself. So the first volume, which I'm going to say is the volume of the overall shape, that's going to be using the formula from the formula sheet, which is just 1/3 the base area. So the base, or the base area, you can maybe call that A, times the height. And then just plug in those numbers in. So it's 1/3. It's a square base, so the base is 90 centimeters long. So it's going to be 1/3 times 90 times 90 again, because 90 times 90 would give you the area of the base, and that's what the A is, times the height. And the height, just check that, is 108 centimeters. So once you've got that plugged into the formula, it's just purely a calculator exercise. I did this one earlier. It comes out to be 291,600 centimeters cubed. Secondly, moving on to the smaller square-based pyramid. So just going through the same process, so very typical of a volume question in National 5, working out two volumes and adding or subtracting. Same idea, same formula, still going to be 1/3 the base area times the height. Just changing the numbers. This time the smaller square-based pyramid has got side lengths on the base of 40. So it's 1/3 times 40 times 40, and it's got a vertical height of 48. Again, I did this one earlier, and it comes out to be 25,600. Then just a case of subtracting the smaller one from the bigger one. So to get the total volume, we're just going to do 291,600 minus 25,600, and that comes out to be, I'm not going to do that in my head, it is a calculator question, so 26600. And just remember your units, centimeters cubed. In question 10, we're being asked to write these two algebraic fractions as a single fraction. So just like numerical fractions, we add and subtract by making a common denominator. So to make the common denominator, we're just going to multiply these together, and then to adjust the numerators, we're going to cross multiply. So we're making two new fractions. Just remember the denominators are these guys multiplied. You don't need to actually multiply them, so you can just write them like this. So both going to share that new common denominator just like that. And then cross multiplying, the x multiplies to the 7 to give us 7x. The 2 multiplies to the x minus 3, so you could just write that as 2 bracket x minus 3, or you can go straight to multiplying it out. It's fine either way. We need to multiply it out later anyway. At this point, we can merge them into one fraction, so 7x minus all of that bracket. I'm just going to leave it in the bracket for this line of working. Remember, we can now make that over x bracket x minus 3. On the denominator, you can either leave this in the factorized form, or if you multiply it out of the bracket, that would be fine. You don't have to multiply out the bracket. Probably best just to leave it like that to avoid making a mistake. Taking out the bracket on the top line, so minus 2 times x is minus 2x. Minus 2 times minus 3, double negative, that's going to be plus 6, like that. Again, just not doing anything with the denominator. And then just tidying this up, 7x minus 2x gives you 5x plus 6 over x bracket x minus 3. And we're done. So pretty straight up algebraic fraction question, that one, really pretty typical. The next question is a little more challenging to interpret. It is essentially a trigonometric equation, but it's not presented as a straight up equation. It's got a little story behind it, it's got a context. We're told that this formula represents the height based upon this angle x, and we're trying to find the angles that lead to a height of 150 centimeters. So we're just going to plug in 150 here in the place of the h, which is the height, in our formula, and that's the first move. That's all we're going to do. But as soon as you do that, you've turned this into a trigonometric equation. And because it's a trigonometric equation, we now need to go through the actual steps. So I'm just going to subtract 147 from both sides. So we're going to get 20 cos x equals 150 minus 147, which is just 3. Dividing both sides by 20. Just going through the normal steps at this point that you would in a trigonometric equation. I know it's not easy in the context, but the actual working is easy enough. You could then at this point, if you wish, do a cast diagram, because this is the first point at which you can do the cast diagram. So we're dealing with cosine positive, so it's going to be a check here and here. So we're expecting an answer between 0 and 90, and one between 270 and 360 in the first and the fourth quadrant. At this point, we just need to put this in the calculator using the inverse. So we're going to get cos inverse of 3 over 20, and that's going to give us the solution in quadrant A. So I did this one earlier, and that comes out to be 81.37 degrees. So later on we can assign that to x. I'm just going to leave that there for the time being. The second solution, the one in the fourth quadrant, is 360 minus 81.37, and that one came out to be 278.62. 278.62 degrees. Those are our two solutions. It's asking for the value for x, so just make sure you assign those to x maybe at the end. So x equals 81.37, or you could use one decimal place degrees, and x equals 278.62 degrees. So not an easy question to interpret, but once you get into the working itself is actually quite standard for a question of that type. In question 12, we're being asked to simplify this algebraic fraction. We achieve that by factorising and then trying to get a common bracket on the top and the bottom of the fraction. So first step here is to factorise, noting that these are different types of factorising on the numerator and denominator. So the numerator is a difference of two squares, so that's going to be x minus 4, x plus 4, or the other way around, doesn't matter on the order, divided by, the bottom line's a trinomial, so that's also going to need two brackets. So we'll need an x and an x. Two numbers would multiply to make a minus 20 and combine to make a plus 1, because remember that's a 1 in there. But keep in mind that you need to get a bracket here that matches up with 1 on the top. and you can see that both brackets on the top contain a 4, so there has to be a 4 in the back of one of our denominator brackets. That means obviously the other number has to be a 5 because they're multiplying together to give you 20. And if you're adding or subtracting these numbers to make a +1, it would have to be +5 and -4, because +5 take away 4 gives you 1, and they also multiply to make -20. So at this point we've done the factorising. You can see that we've got an x plus 4 top and bottom. You could score these out lightly if you wish, leave in just these two. Don't really need the brackets anymore, so you would get x plus 4 on the numerator and x plus 5 on the denominator, and that's as far as you can go. Very tempting for some students to start scoring out x's and things, but can't do that. That's the final answer for that question. In the next question, which is a trigonometric identities question, not a very popular topic, there are only two trigonometric identities that you know at Nat 5. One is sine over cos equals tan. Doesn't look relevant to this question. Or sine squared plus cos squared equals 1, which does look very relevant. Not set up exactly in that form, sine squared plus cos squared equals 1, but it's very close to it. And you can see that there's a common factor here of 2. If you pull out that common factor, just normal factorising, that is going to leave sine squared x plus cos squared x inside the bracket. Pulling in then that identity, that tells us that from that sort of formula in our brain that this is equal to 1, so that's going to be 2 bracket 1 or 2 times 1, just to give you a final answer of 2. In part A of question 14, we've got to take the information from the diagram and make the formula that's being given in the question. These questions are not always very well done. They can be a little tricky to interpret, but basically it's just a little bit of algebra and some geometry. So they're telling us that the volume of this shape is 45 square meters. That's the numerical version of the volume, but the volume you can get, of course, by just using the volume formula for a shape like this, which is length times breadth times height. So length times breadth times height. And then just filling in what we've actually got for those. So the length here is x plus 7. It always seems a little weird using algebraic terms in a formula like this, because normally these would be numbers. We're more used to numbers, but it works in the same way. The breadth is x, so it's times x for the breadth times the height, which is the numerical value 2. Okay, so just tidying this up, x times 2 is 2x, so we can make that 2x bracket x plus 7. But they're telling us in the question that the volume itself numerically is 45. So we can stick a 45 there. So 45 is equal to 2x squared by multiplying the bracket. 2x times 7 is 14x. And then if we just pull the 45 to the other side, we would end up with 2x squared plus 14x minus 45, and that would leave 0 on the other side. So that's going to be equal to 0. So that's where that formula comes from. And then in part B, we're asked to work out, calculate the value of x. So in other words, solve this equation. Sometimes in a question like this, the equation can be solved using factorising, but notice that in this question, they're going on about writing the answer with 1 decimal place. If you factorise, you wouldn't get a decimal place. You would get, well, you could get a very simple decimal, but it's unlikely you would get that. So this question is to use a quadratic formula. So the a value for a quadratic formula is 2, the b value is 14, the c value is negative 45. Make sure you get the negative. Plugging that into the formula, remember the formula is x equals minus b plus or minus the square root of b squared minus 4ac, and then all of that divided by 2a. So just putting in the numbers carefully, minus b, that's minus 14, plus or minus the square root of b squared, so it's 14 squared, which is 196. You could write in 14 squared, that would be fine, times 4 times the a value, which is 2, times the c value, which is minus 45. All of that divided by 2a. A is 2, so that's 2 times 2, so it's going to be 4, like this. Remember, this is a calculator question, of course, so you can work this all out in the calculator. So I did that earlier, and it came out to be 556. The thing to avoid there, or to really notice there, is a double negative, but it should be fine if you put that in the calculator anyway. So it comes out to be that divided by 4. At this point, we can then solve for two values of x by splitting this, one with a plus and one with a minus. If you do the one with the plus, you get minus 14 plus root 0.556 divided by 4. That comes out to be, I checked this one earlier, 2.39. If you do the other one, which would be minus 14 minus root 556 over 4, you get a second value. It comes out to be minus 9 point something, I think. But because it's negative, and x cannot be negative in this question because x is that length there, and obviously you can't have a negative length, we can discard that second solution. Because notice in the question they're asking for the value of x, not values, not plural, so there should only be one, has to be the positive. They're asking for it to be rounded to 1 decimal place, so x would be 2.4 to 1 decimal place. In question 15, we're given this slightly tricky looking non-right angle triangle, and we're asked to work out the length of A to E. Not an easy question to interpret, that's probably why it's the final question in the paper, but the key thing to pick up on here is that they're giving us the area of the total triangle, the area of ADE, which is 160 centimeters squared. So because it's a non-right angle triangle and it's a non-right triangle, which is one where we've got the vertical height off of the base, then the only other formula that relates to the area of a triangle is the one on the formula sheet. And on the formula sheet, it says that the area equals 1/2 AB sine C. Got to be careful in this formula because the A, B, C in the formula might not align with the A, B, and C in our question. In fact, in this case, I don't think they do align. But the important thing with this formula, it says that you need the angle between two side lengths of a triangle. So how does that help us? Well, it helps us because if you look here, we've got this side length, which is 18 plus 6, which would give us a total there of 22. We're trying to work out this side length here, and we don't yet know the angle in between, but we do know the area, which is the other side of this formula. So in other words, we can start populating the formula, and it's in that formula, it's got the thing that we're trying to find, which is A to E. So let's start doing that. So the area we know numerically by the information in the question is 160. The 1/2 is just a half. If we call this like one of the sides, like little a, for example, the whole side there is going to be 18 plus 6, which is 24. So it's going to be 1/2 times 24. The other side, though, which would be this side here, is the thing we're trying to find. So let's just call that A to E. And then sine C, we don't have. Angle X down here, we don't have. But we can then, because you've got to think, right, why have they given me this 8 here? Well, this 8 here pertains to this smaller triangle, so we could then work with that smaller triangle. So if you think about it, we either want this angle or we want ultimately the sine of that angle. That's what we really need. So because this little triangle here is right angled, just doing a bit of like side work in here, setting this triangle up to use SOHCAHTOA on, we can say that the sine of that angle X is equal to the opposite over hypotenuse, because remember in SOHCAHTOA, sine is opposite over hypotenuse, which is equal to 8 over 18. So you could then go ahead and like work out the angle X by doing the inverse, but we don't need to get angle X because the thing we want is the sine of angle X, which is, in our question, this part here, okay? It is slightly tricky in this question because of the slight difference in the ABC in the formula from the formula sheet and the one in the question. We could have modified that, but it's fine, I think, just to plug in the numbers. So our sine X here, or sine C, is 18 over X. So granted, that's not easy, and it's not a normal kind of operation. That's, like I say, why this is the last question in the paper. We can now essentially rearrange this formula, solve this equation, whichever way you want to think of it, to get AE, and then hopefully our answer will be reasonable in the context of the diagram. So it is a calculator question, so you could do some of this on the calculator if you wish, but a quick win here is 1/2 times 24. Half of 24 is 12. So that's going to be 12. I'm going to multiply that next to the 18 over the 8 over 18, and then times that to the AE. You could use brackets instead of the multiply signs. And then we just really want to go ahead and sort of rearrange this. So you could, I suppose, maybe multiply those together first. It's up to you how you want to do the calculation. So 12 times 8 is 96, so it's 96 over 18 times AE. And just like solving an equation or rearranging a formula, we can move this 18 to the other side by multiplying. So it's going to be 160 times 18, and we can move the 96, which is multiplying the AE, by dividing on the other side. So that would give you something that looks a little bit like that. And then just putting that into the calculator, I did this one earlier and it came out to be 30. So a nice reassuring whole number there, 30. So just quickly checking that on the diagram, because it has been a fairly tricky question. Does the answer make sense? Well, if that there is 24, spinning that round to like there, 24 there, then yeah, that definitely could be 30. And in fact, the fact that we've got an answer which looks to be right after a tricky calculation like that almost certainly implies that the answer is right. And indeed, 30 centimeters is correct for the length of A to E.